When the Tesla Model S Plaid was finally unveiled to the public, it was very well received. That's because it's the second generation of Tesla's Model S. With some subtle improvements to the exterior design, but mainly a major change to the interior. This is where much of the public disliked what was done. Tesla chose to put a yoke instead of the traditional steering wheel. However, it kept exactly the same basic mechanical principle as a traditional steering wheel. And this is where it started to divide public opinion. Although we don't think much about it, there's a pretty obvious reason why car steering wheels are circular. That's because for a car to turn its wheels fully to the left or right, the steering wheel needs to make 1.5 turns. This large steering ratio allows for normal straight line driving so that small movements of the steering wheel don't cause a violent yaw movement in the car. This could cause major issues with the vehicle's stability and control, possibly leading to an accident. So there's a kind of buffer zone in the steering which helps ensure very safe driving. Therefore, to make sharp turns, the driver needs to make very quick hand movements to complete the turn. Works well with a circular steering wheel. Now, when it comes to a yoke, which is basically half a steering wheel and also somewhat square, things get a bit complicated and uncomfortable. This disrupts the coordinated movement most drivers are used to. Also, because the yoke, which is more common in aviation, is ideal for cases of low steering ratio, where it turns about a quarter and corresponds to the maximum wheel turn, basically just like it is in Formula One. The challenge with using this model in regular cars is that a slight steering wheel turn causes a large movement in the car. Knowing this, Tesla chose to adopt the yoke but kept the usual high steering ratio, which is common in all cars. In other words, the yoke turns 1.5 times, which corresponds to the maximum wheel turn, providing the same feeling of control and safety while driving. But it creates discomfort in tight turns, since the driver needs to cross their hands on a steering wheel that is essentially square. And this is where Lexus comes in with its new RZ450e model, which uses the yoke with a high steering ratio, meaning the yoke turns just a little more than half a turn. In normal driving, slight yoke movements don't make the car react sharply. But how did they achieve that? The answer is a system called steer-by-wire, which means something like steering by cables. It's a system that's 100% adopted from the aviation industry, where it's known as fly-by-wire. To understand how this system works, we first need to know how a regular car's steering works. In a typical car, the steering wheel is mechanically linked to the wheels. That is, there is a set made up of the steering column, steering box, tie rod end, and finally the steering arm. It's an entirely interconnected mechanical system that works very well. In the new Lexus model, the steering wheel has no mechanical link to the wheels. It works like this. When you turn the steering wheel, in this case the yoke, a sensor detects how much the wheel has been turned and sends a command to a controller in the steering box. This tells the electric motor how much to turn the front wheels. And this is done entirely electrically, without any mechanical shaft. But it doesn't stop there. The electric motor on the steering rack, which is responsible for turning the wheels, is technically called the steering control actuator. That's because it senses road vibrations and imperfections through the wheels and relays this to a motor on the steering column, which is called the steering torque actuator. This motor provides highly realistic feedback to the steering wheel. In other words, a vibration in the steering wheel if you're on a gravel road, a slightly stiffer steering wheel if you take a very sharp turn, or a very light steering wheel if you're on a slippery road. In other words, the system gives you the same feeling you would have in a regular car. And the system can mimic these variations in real time based on the surface the wheels are on. The main benefit of this system is that the car is much lighter. Many regular steering system components are removed, and this immediately results in lower fuel consumption, since the car needs to use less force. There's just one problem. Since the Lexus yoke only turns 150 degrees in each direction, That's a little more than a quarter turn. That means it has a low steering ratio. What's called a low steering ratio? Which means the car will be very sensitive. And during normal driving, small movements of the steering wheel will mean abrupt movements of the vehicle, which makes driving quite dangerous. To get around this problem, the Lexus system uses software that allows the car to switch between a low steering ratio and a high steering ratio, depending on the situation. It works as follows. At low speeds, the system uses a low steering ratio, what's called a low steering ratio. This makes the steering very responsive. Like this. Small movements on the yoke will make the car react in the same way to the commands. This works well in tight corners and situations needing lots of steering wheel movement. This makes those maneuvers much easier with fewer movements. At high speeds, on the other hand, the system becomes much less sensitive. Thus, slight movements on the yoke, they won't cause sudden vehicle movements, which makes things much safer. The system can switch between the two in a very subtle way, which makes driving similar to a regular car. And it's a very similar principle used in airplanes through the fly-by-wire system, which also use software and electrical signals. At low speeds, inputs on the stick translate into very responsive movement from the control surfaces that make the airplane turn or climb. But at high speeds, the system readjusts itself and becomes less sensitive. So large movements on the stick do not translate into large and abrupt movements of the airplane. These are adjustments that often go unnoticed, and many of them are already happening in the background. But they are extremely important for the safe operation of these vehicles. And the yoke has significant advantages compared to the traditional steering wheel. The first one is that it allows for much better visibility of the dashboard, thanks to its design, which doesn't obstruct the dashboard. Another major benefit concerns occupant safety, since the yoke doesn't allow that movement known as hand over hand on traditional steering wheels. This means that if there's an accident, your hands will never cross in front of the airbag, which is dangerous if it deploys while your arms are there. But is this system really safe? And what if this so-called controller, the controller fails? Doesn't the driver lose control? And what if the motor that turns the wheels stops? What if there's an electrical failure in the system? Does the car stop turning? Well, just like in aviation, these kinds of events are avoided by introducing redundancy. For example, in the Boeing 777, if the pilot wants to turn right, that command is processed by 9 computers made by 3 different manufacturers, where all 9 must give the same result. Each computer is completely independent, and each one is monitored by the others. Only then is that command sent to the surface on the wing, which will turn the plane. If 1, 2, or 3 computers fail, it's not a problem. The plane continues to fly safely. In the new Lexus model, all the critical steering components of the vehicle have redundancy. That is, there are 2 steering control actuators, 2 steering torque actuators, and so on. That's why many people dislike Tesla's yoke. It's that the hand-over-hand movement is extremely uncomfortable with yokes. That's why steering wheels are circular. Recognizing this, Tesla began offering a traditional steering wheel option, in addition to the yoke, as an option at the time of purchase. Another concern with the Lexus model is potential electrical failure in the vehicle. Well, the Lexus RZ450e, it's a 100% electric vehicle, in other words. Its main feature is a huge battery. This battery is one source that powers the vehicle's steering system. This battery, in turn, charges the vehicle's conventional battery, which is the other power source for the system. And there is still a third backup battery for the system. There are 3 separate sources that power the vehicle's steering. But what I really want to know is your opinion here in the comments about this new steering system from Lexus. What did you think? Is it really as safe as the company claims? Leave your opinion down below.